It's a great day and happy to have you all once again, children. Today we are going to discuss about how to measure the force between the charges. Fine. Look at this slide, children. I think you must be familiar with the superhero Flash who appears in the science fiction series. Barry Allen gets transformed into Flash and acquires his superpowers after getting struck by the lightning, right? Remember, lightning is the result of our current topic, static current, isn't it? Okay, to be a superhero and lead, it is not necessary that you must have special powers. It is enough if you can take charge and be positive. Then you were the leader already, right? So with that good note, we can start today's session. And yesterday in the last session, I think you may remember what we have discussed. So we got introduced into electrostatics, the topic of this first lesson, and then the second point was historical background of electric charges were discussed, and also we have discussed about the properties of electric charges. So in today's session, what we are going to discuss is about Coulomb's law, aspects of Coulomb's law, memes on electric charges. Yeah, you heard it right. So it is memes on electric charges. After all, we should have some fun too, right? And then finally about superposition principle. So these are the topics for today. And first of all, in the last class we have discussed about the force between the charges. That is, unlike charges, they always repel each other, attract each other, and like charges repel each other. Okay, so that is what we have discussed. So you can see the same thing is explained in the diagram over here. So look at the first one, plus q1 and minus q2. You can see that they are getting attracted towards each other, but in the other two cases, as it is the force between two like charges, they are repelling each other, isn't it? So once again the idea is proved over here. Like charges repel each other, unlike charges attract each other. So we know that there is a attractive or repulsive force. In general, there is a force. Okay, so many other scientists were trying to find out the expression for this force. Okay, that is the magnitude of the force. So even though others were trying, the one who got succeeded in that effort was none other but Charles Augustin de Coulomb. Okay, so Coulomb was the one who got success in that particular effort. So he proposed his own law, and that is what is called as Coulomb's law, and Coulomb's law explains about the force between two electric charges. Okay, so let us consider two charges here. For example, plus q1 and plus q2, both of them you can see that they are positive charges. So they are separated by a distance of r here. So you know that always these two forces will be repulsive, that is, they are repulsive in nature and they experience a repulsive force here. So here we have to consider two forces, not just one force, because both the charges are experiencing force here, right? So F21 and also F12. But what is F21? So F21 is the force experienced by the second charge because of the first charge. And what is F12 then? The force experienced by the first charge because of the second charge. So which charge is experiencing the force, that must be mentioned first. So F21 means the second charge is experiencing that particular force. F12 means that first charge is experiencing that particular force, right? Now R12 cap. So what is R12 cap? It is a unit vector from positive to, that is first charge to second charge. So R21 cap will be from second charge to the first charge. Okay, this is all the imagination he had made to explain his law. So he had explained his law in 8 different aspects. Okay, we are going to discuss about it one by one. So the different aspects of Coulomb's law is going to be discussed now. So the first one, the first aspect explains the law itself. This is a very important 2-mark question, and this aspects can be asked in the 5 marks too. So we can expect it in 3 marks even with any 3 points to be written. So let us enter into the law. Coulomb's law. Coulomb's law states that the electrostatic force is directly proportional to the product of magnitude of 2 point charges, that is F is proportional to q1 q2 and inversely proportional to square of the distance between the 2 point charges, that is F proportional to 1 by r square. So here you can see that we are representing two charges and the product of the two charges, that is we are representing two charges q1 and q2. So look into that word, product of magnitude of 2 point charges. So it is q1 into q2. So they have given that force is directly proportional to that, right? So if F is proportional to q1 and q2, q1 into q2. So next he is explaining that it is inversely proportional to the square of the distance. So F is proportional to 1 by r square. So he found out that these are the two factors which are affecting the force, and he tried to get a formula for it and make it dimensionally correct. So now we can express it in this manner: F proportional to Q1 Q2, F proportional to 1 by r square. So as it is given in the equation over here, F is proportional to Q1 Q2 by r square totally. So when the proportionality is removed, we used to introduce a constant all the time, and the constant is k here. So F is equal to k into Q1 Q2 by r square. Okay, so we have got a formula for this Coulomb's law now. So remember, while you are writing the law, actual law, you must write the formula also. So F is equal to k into Q1 Q2 by r square is the formula for Coulomb's law now. Now that is the first aspect which explained about the magnitude of the force. Now let us enter into the second aspect. So second aspect is explaining about the direction. So we know that these two charges are experiencing force, and it must be opposite to each other, right? So that force must be opposite to each other anyway. But what will be, in which direction it will act, in which line it will act? So you can see whatever is given in the yellow color font over here, the force exerted by the charges on each other always acting along the line joining two charges, right? So line joining two charges, when you are connecting these two charges by a line, so these two forces F12 and F21, that will be acting only through the line joining these two charges, right? We can discuss a small example for that even. For example, imagine you and your friend are sitting, and both of them, maybe you may have some quarrel among yourself, or maybe some argument. So you are punching your friend and your friend is punching you back, right? So in that case, you can see that both the forces are acting along the line joining both of you, isn't it or not? Yes. So here also the force is acting along the line joining both the charges, just like how the force was acting in between you and your friend. Okay, so that is about the second aspect here. So first aspect explained about magnitude, and second aspect explained about the direction. So here, as we have discussed already, they have represented F21 and F12 vector here. So F21 is k into Q1 Q2 by R12 square R12 cap. F12 is same as that one, but it will be opposite in direction. So R12 cap has to be replaced by R21 cap here. Okay, because they are oppositely directed. Okay, that is about the second aspect. Now the third aspect. Third aspect speaks about the constant we are used over here. I think you may remember F is equal to k into Q1 Q2 by r square. But what is that k? K is equal to 1 by 4 pi epsilon naught actually, and this k is called as Coulomb's constant. Okay, so it is not given in our book, make a note of it. It is Coulomb's constant, and its value is equal to 9 into 10 power 9 Newton meter square per Coulomb square. So the value of k is 9 into 10 power 9 Newton meter square per Coulomb square. You may wonder how they have got this Newton meter square per Coulomb square. Very simple. Look into that formula. F is equal to k into Q1 Q2 by r square. So what is k here? Yes, k is equal to Fr square by Q1 Q2, Fr square, so Newton meter square, by Q1 Q2 by Coulomb square. So that is why it is Newton meter square per Coulomb square. And this epsilon naught, we used to call it as epsilon, as we are writing 0 over there, it is epsilon naught. So epsilon naught is the permittivity of free space or vacuum. Actually there will be a small variation in the permittivity of free space and vacuum, but it is nearly same. So that we used to say, take it as permittivity of free space or vacuum to be one and same. So here the permittivity, what is the permittivity? So once again, it is not in your book, but it may be asked in 2 marks in your examination, so please copy it later. So permittivity of a medium is defined as the ability of the medium to store the electric potential energy under the influence of electric field. So if a medium is under the influence of electric field, how much energy it can store, how much potential energy it can store, that is normally called as permittivity of the medium. So we will discuss in detail about this electric potential energy in the later part of this lesson. So that is what is explained as permittivity of the medium. Okay, so here we can see that epsilon naught value is, see, k is 1 by 4 pi epsilon naught. So what is epsilon naught then? Yeah, nothing but 1 by 4 pi k. So 1 by 4 pi into k, that is k value at 9 into 10 power 9 has to be substituted here. So we are solving it, it will be getting it as 8.854 into 10 power minus 12. And you know that why it is Coulomb square per Newton per meter square, because the reciprocal of the previous one, Newton meter square per Coulomb square, is Coulomb square per Newton per meter square, and that is why it is written over here in that manner. Okay children, so here in the tabulation they have given the permittivity of different materials, right? Paper, rubber, water, graphite and diamond. So in all the cases, one thing you have to note it down, it is always greater than that of what is given as the permittivity of the free space. Permittivity of free space is 8.854 into 10 power minus 12, but all these values are 34, 62, everything is going to be greater than epsilon naught. So always the permittivity of any medium is greater than that of the permittivity of the free space. Okay, that is the aspect 3. Now let us pass on to aspect 4. First aspect explained about magnitude, second one about direction, third one about constant, and fourth one is going to explain about what is Coulomb. So we are going to define Coulomb based on Coulomb's law. So what is Coulomb's law? F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Now what we are going to take is, we are going to take Q1 Q2 to be 1 Coulomb itself. In order to explain what is 1 Coulomb, we are imagining the charges which we are considering to be 1 Coulomb itself. So take two charges of 1 Coulomb and separate them by a distance of 1 meter. So the formula becomes 9 into 10 power 9 into 1 into 1 by 1. So the value is equal to 9 into 10 power 9 Newton now. So they are defining Coulomb in this manner now. It is defined as the quantity of charge which should place at a distance of 1 meter from an equal and similar charge. They are equal charges. So 1 Coulomb and 1 Coulomb. And similar charges, both are same, and that is why they are experiencing a repulsive force of 9 into 10 power 9 Newton. So that means that if you take two charges, separate them by distance of 1 meter, and if it experiences a force of 9 into 10 power 9 Newton, then the charges which you have taken must be equal to 1 Coulomb. Do you understand, children? So 1 Coulomb is actually a very huge charge, and you can give a look into the data they are given over here. If you scuffed your feet on the carpet, transferring 1 Coulomb of charge to your body from the carpet, what happens there is the electric force that is pulling your body down to the carpet would be equal to 1 million tons. It's very huge, right? So actually speaking, 1 Coulomb is a very huge charge, and normally we will not be dealing it with that practically. So practically what we will be using is micro Coulomb, that is 10 power minus 6 Coulomb, and nano Coulomb 10 power minus 9 Coulomb, and even pico Coulomb, that is 10 power minus 12 Coulomb. Okay, children. So that is about aspect 4. Now we can pass on to the aspect 5, relative permittivity of the medium. So we know that when you are placing it in the free space or vacuum, the value is equal to, Fa is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So what happens if you are placing the charge, that is charges, inside the water medium? So you are placing it inside water medium, what happens to it? So they are trying to find out a formula for it, and that is nothing but Fm is equal to 1 by 4 pi epsilon naught epsilon r Q1 Q2 by R square. So this epsilon r is called as relative permittivity of the medium. Remember, the word relative stands for comparing. Okay, always our relatives go for comparison, right? Once our results are out, they used to compare our performance with the neighbor's performance or maybe some other relative's performance. So the word relative itself means comparison. So here we can see that we are comparing the permittivity of the medium, the given medium, to that of the permittivity of some standard value, permittivity of the free space. Okay, this is like comparing your marks. That is, if you have scored 95 out of 100, 100 is the standard value, we are not going to change it. So 95 is what you have scored, right? So here epsilon by epsilon naught is one and same. Sorry, that is same as the marks comparison. So epsilon by epsilon naught. So here epsilon naught is going to be a constant all the time, and epsilon will be varying according to the medium. So what is epsilon r now? Epsilon r is epsilon by epsilon naught. How they have got it? Very simple. Look into the formula. Fa is 1 by 4 pi epsilon naught Q1 Q2 by R square. When coming to the medium, it is 1 by 4 pi epsilon naught epsilon r Q1 Q2 by R square. So what we are going to do is divide Fa by Fm. When you are dividing Fa by Fm, what you are getting is epsilon by epsilon naught, and that is what is equal to epsilon r. And this epsilon r is always the ratio between the permittivity of the medium to the permittivity of the free space. So its formula is epsilon by epsilon naught. So I think you would have noticed I have used the word ratio, as they are ratio, that is they are the ratio of two same physical quantities, permittivities. It will not be having any unit at all. It does not have any unit, right? So it does not have any unit, and relative permittivity of free space is normally 1. Why it is 1? Why it is 1? Because epsilon r is equal to epsilon naught by epsilon naught for the free space, because epsilon naught is going to be same, right, and the epsilon value alone will be varying. So I told you already, for vacuum and free space the permittivity is nearly same, so we used to take it as 1 itself, so it is 1 all the time, and relative permittivity of the medium is always greater than 1. So this is what we have discussed already in this particular tabulation. I think I wanted to recall that too. Okay, so now relative permittivity of the medium is always greater than 1, and relative permittivity has one more name too, dielectric constant. So relative permittivity is otherwise called dielectric constant, and that's all about the fifth aspect. So now let us pass on to the sixth aspect. I wanted to recall what we have discussed so far. The first aspect spoke about the law itself, that is, it spoke about the magnitude of it. The second one explained about the first one is magnitude, second one direction, and the third one explained us about the constant, and fourth one explained us about the definition of Coulomb, and fifth one explained about relative permittivity, right. Now let us enter into the sixth aspect, interesting part of it. Here we are going to compare Coulomb's law with Newton's universal law of gravitation. Okay, why we are going to compare? So I think you will get to know that if you are looking into this meme, okay, I think you will get some idea regarding it. Can you see this? So one person is represented as Newton and the another person is represented as Coulomb, right. So he is writing it as F is equal to G into m1 m2 by d square, and looking at his paper, Coulomb is writing it as F is equal to K into Q1 Q2 by r square. Can you get some idea behind it? Yes, here represented as inversely proportional to the square of the distance. So Coulomb also represented it as inversely proportional to the square of the distance, and that is what is explained here. Fg is proportional to 1 by r square and Fe is also proportional to 1 by r square. But actual thing is, whenever we are representing the force with respect to distance, always they are inversely proportional to each other. So when they are separated by a greater distance, automatically the force will be reduced, just like what recently we are speaking about social distance. Okay, after this corona problem, we have been speaking about social distance. So they are saying that if you are increasing the distance, automatically the effect of it will be decreased, right. That is same thing here. So if you are increasing the distance, the force will be decreased. So that is true for all the kind of forces normally. Okay, so here it doesn't mean that Coulomb is copying from Newton. So in all the cases, the force is inversely proportional to the distance, but square of the distance, because dimensionally, to make it correct, we have to write it in that manner, or it may be varying in that manner. Okay, so now only that similarity is there in between them both, but what are the differences? See, you may come across the questions in which you will be asked to compare or differentiate. What is the difference between them both? Compare and differentiate. So compare means you can go for similarities also, you can write the similar points also, but you are coming to differentiate. What you have to do? You have to write only the difference between them. But here in this tabulation, we have just compare them both. Okay, let us look into it point by point. The first point explains directly proportional to the product of two charges, because it is Q1 into Q2, but here it is product of two masses because it is proportional to m1 into m2. And second point, both of them are going to be inversely proportional to the square of the distance between the particles there, but here it will be charged particles in the case of electrostatic force. What about the third point? Third point explains Coulomb force between two charges can be attractive or repulsive, we know that. But what about in the case of gravitational force? Yeah, it is always attractive, right? The fourth one, the constant K in the Coulomb's law is K is 9 into 10 power 9 Newton meter square per Coulomb square. But gravitational constant is it is given as 6.626 actually, but its value is actually, you can see it over here, 6.67. There is a small variation in that one. Actually, even in last year book's errata, it was not changed. We are expecting it to get changed in the new edition of the book. We will be receiving it shortly, right? Okay, the value of gravitational constant is normally 6.67 into 10 power minus 11 Newton meter square per kilogram square. So in comparing to that value, this is very, very low value. And fifth point is, there we can see that it depends upon the medium. We had seen that how when the medium is changed from air to water, the value is changed. But here it is independent of the medium. The gravitational force is independent of the medium. And the last point is, when the charges are at rest, we can see that only Coulomb's force will be acting in between them. But when the charges are moving, something called Lorentz forces also will be coming into play. So we will be discussing in detail about these Lorentz forces. We used to call it as magnetic Lorentz force in the third lesson. And here in this case, when the forces and the masses are at rest or when the masses are moving, irrespective of it, the gravitational force are one and same all the time. Okay, it remains as a constant one. So these are the 6 similarities. There is one similarity, all the other 5 points are explaining the difference between these two forces. Okay, so now we are going to discuss about that 4th point in detail. 4th point told that the Coulomb's constant is smaller, and here it is Coulomb's constant is greater. And what about the gravitational constant? The gravitational constant is very much lesser, right? So after all, F is proportional to, when you are keeping all the other values to be constant, this F is proportional to K. So we know that because of that, the gravitational force is very much lesser than that of the electrostatic force. We are going to prove it with an example over here. So look into that now. Calculate the electrostatic force and the gravitational force between the proton and the electron in an hydrogen atom. They are separated by a distance of 5.3 into 10 power minus 11 meter. The magnitude of charges on the electron and the proton are 1.6 into 10 power minus 19 coulomb, and then they have given the mass of proton and mass of electron here. So you are asked to find out the force, both the forces, and we are asked to compare them both, right? So we are finding out what is Fe first. What is Fe electrostatic force? It is K into Q1 Q2 by R square, but both Q1 and Q2 are same here, as the charge of the electron and proton are same, so we can write it as E square itself by R square. So substitute the given values and we are finding out the value of Fe. In the same way, what is Fg? It is G into M1 M2 by R square. Here you can see that they have substituted the value of G as 6.67, so that is actually the correct value, into 10 power minus 11. Then we are substituting the mass and distance, and we are finding out the force, and it is equal to 3.4 into 10 power minus 47. So we are dividing them both, Fe by Fg. We can see that the force, because of the electrostatic, that is the charges, force between the charges, electrostatic force, is 10 power 39 times greater than that of the gravitational force, and that is why we are calling the gravitational force to be the weakest force, right? So here the electrostatic force is the strongest one when compared to the gravitational force, but who bothers? Even though it is the weakest force in nature, we know that that is the one which is dominating the whole universe. So think of a black hole. Whenever you are calling the force, that is gravitational force, to be the weakest one, just think of the black holes, right? Okay, so that is all about the 6th aspect. 7th aspect. So what is the 7th aspect? Vector form of Coulomb's law. So it is an important 3-mark question. We can expect it in 3-mark question. So we know that the force because of the second charge due to the first charge and first charge due to the second charge are equal in magnitude and opposite in direction. We are going to prove it now. How? So first we are writing the equation for F12, force experienced by first charge because of second charge. It is 1 by 4 pi epsilon naught Q1 Q2 by R square R21 cap. Now we are replacing R21 cap by R12 cap. You know that these are the two vectors which are oppositely directed. See, for an example, what is the distance between Madurai and Chennai? Let it be 450 kilometer. Then what is the distance between Chennai and Madurai? Once again it is going to be 450 kilometer, but the travel in which you are traveling matters, right? From Madurai to Chennai and Chennai to Madurai, here we are traveling towards the north, but in the next case we are traveling towards the south. So that is different, right? So R12 cap is equal to minus R21 cap then. So replace R21 cap by minus R12 cap, and on rearrangement we can prove that F12 vector is equal to minus F21 vector. So therefore the electrostatic force obeys Newton's third law as they are equal in magnitude and opposite in direction. Okay, ma? So here that is the vector form of Coulomb's law. And now let us discuss about the 8th one. The expression for Coulomb's force is true only for point charges. So where it is applicable, that is what is explained here. It is applicable only for point charges. But what are point charges? So this once again an additional definition which is not given in the book. Please make a note of it. Point charges. A charge is said to be point charge when the magnitude of the charge is very small when compared to the distance considered. So when compared to the distance, if the charge's magnitude is smaller, only in that case we used to call it as point charges, and only for the case of point charges Coulomb's force or Coulomb's law is true. Okay, so that is what is explained in the aspect 8. Okay children, so we have discussed about all the 8 aspects, and as I told you already, we can expect a 2 mark or a 3 mark or a 5 mark from this part, and it is a very important question. Okay, so how to learn a question like this? a point question. See, we may be expecting 2 point questions in 3 marks and 2 point questions in 2 marks too. So in that case, how we have to remember all this? So there is we have 2 techniques to remember it. The first technique is linking the points. So first point has to be linked to the second one and second has to be linked to the third. So in that way, if you are learning easily, you can by heart it. So we have another method also. So relate each and every just to have a keyword over each and every point. In each and every point you should remember a keyword, so easily you can remember the entire question. So here I have tried to do it for you. So the first point explained about the magnitude, the second point about the direction, third point we have spoken about the constant, and in fourth point we discussed about Coulomb, the definition of Coulomb. The fifth point relative permittivity, and sixth point Newton. Remember the word Newton because we have compared Newton's law with Coulomb's law. In seventh point we have discussed about vector form of Coulomb's law. So vector, remember the word vector. In the eighth point you remember the word point charges. So if you can memorize this keywords, you will not miss any points. Easily you can write it. Okay. So that's all about it. So far we have discussed about what are the 8 different aspects of Coulomb's law. I think you might have got some clear picture regarding that now. Okay. Now time for some fun. So as I told you already, we are going to discuss about some memes on electric charges. So in the beginning itself I told you about, while I was introducing you to this session, I told you about flash. Do you remember? So see, I think many of you may be having the habit of watching the series or movies, whatever it is, science fiction especially. When we are speaking about science fiction movies, I always look into it as an educational tool. So we can learn so many things other than using it as an entertainment, using it for entertainment. We can take some extra points from it, you can learn something from that all the time. So if I call the science fiction movies and series to be educational tool, I will be calling the memes as a testing tool normally. So in order to understand, because in order to understand a meme, you must understand the concept first, right? So if you can understand whatever we have discussed in the last 2 sessions, definitely you can understand the memes we are going to see and you are going to have fun too. Okay, just for 1 minute. So I'm not going to explain anything over there. You just have a glance at it and you can enjoy it by yourself. So if I'm explaining it, you will not have any more fun, right? So you can look into that. The first point is first person is saying I am a positively charged proton. Second person is saying I too I'm also a positively charged proton. So you can see what is happening in the next picture, right? Okay. Look into the second one. So those who are familiar with this template may understand the meaning by now. So it explains how the like charges are repelling each other and unlike charges are attracting each other. And the third one explains about cation is positively charged. So cation is positively charged, right? So how here it is explained how the cation is positively charged. As it is charged, we can see that it is getting some goosebumps over there. Okay, from its higher arrangement itself you can say that anyway. Okay, look at the fourth one. Cations are positive. It is not PO here, PAW here. Okay, so that is another meme. And the fourth one, cations are positive and anions are negative. You can see that they have highlighted T in the first 2 words and N here. So easily you can remember too. So in this meme, using this meme, you can easily remember that too. As a learning tool, we can use this meme. Cations are positive and anions are negative. Okay, so I think you would have had some fun anyway. So you can create simple memes to explain the science concept and please try to share it with me. That will make the learning even more fun. You can, more than that, you can understand the concept easily and you can present it in your own way. Okay, now let us discuss some examples to understand the concept even more better. So this is one more better way to understand the concept or understand it better. Okay, now consider 2 point charges Q1 and Q2 at rest as shown in the figure. They are separated by a distance of 1 meter. Calculate the force experienced by the 2 charges for the following cases. So they have given 2 microcoulomb plus 3 microcoulomb in first case, and in the second case it is plus 2 microcoulomb and minus 3 microcoulomb. So in the first case they will be experiencing a repulsive force and in the second case they will be experiencing the attractive force. You are asked to find out the force in both the cases. So look into the first one, F21, that is force experienced by the second charge because of the first charge will be acting towards the right. that is along the positive x-axis, while F12 will be acting along the negative x-axis. In the second case, F21 will be acting along negative x-axis and F12 will be acting along positive x-axis. So now look into the first one. So how will you write the formula for F21? It is 1 by 4 pi epsilon q1 q2 by r square r12 cap. So while you are writing about the magnitude, no need to bother about the direction. That is, if you are not representing it in vector form, there is no need for us to bother about the direction. But here we are representing in vector form. So scalar na, there is no need for you to remember that. So F21 vector. So here we have to represent in terms of vector r12 cap. So why r12 cap? So here along positive x-axis, so we have to write it as I cap here. So you are substituting the values and you are finding it to be 54 into 10 power minus 3 Newton I cap. So this is about F21. What is about F12 then? So F12 is minus 54 into 10 power minus 3 Newton I cap. Can you guess why, children? Yes, because they are oppositely directed, so we can write it in that manner, or otherwise I cap can be replaced as minus I cap and we can proceed in that manner too. Okay, now come to the second problem. In the second, that is second subdivision, there the same way 2 microcoulomb and minus 3 microcoulomb, the magnitude of the charges remains the same, only direction differs. So F21 vector is acting in the direction of along the negative x-axis now. So we got to take it as minus I cap now, not as pi plus I cap, and in this case we can see that F21 cap here and minus 3 also we got to substitute it over here, so it becomes minus 54, and that is why it is acting along the negative x-axis. Okay, so because we are replacing this 3 with the minus 3 here, because here it is the negatively charged one. So what about the F12 then? F12 is equal in magnitude to that of F21, but it becomes positive value, that is 54 into 10 power minus 3 Newton I cap, as it is acting along the positive x-axis now. That's why it is acting along the positive x-axis now. That's all about your first problem. And then the second problem. Two small sized identical equally charged spheres, each having mass 1 milligram, are hanging in equilibrium as shown in the figure. In the figure you can see that they have two charged spheres and they are separating, they are moving away from each other as both of them are having the positive charges. And what is the distance between these two charges, children? Yes, it is 2a. The length of each string is 10 centimeters. So this L value is equal to 10 centimeters. And the angle is 7 degree. So if angle theta is 7 degree, what is 2 theta then? It should be 14 degree. Calculate the magnitude of the charge in the each sphere. So take G as 10 meter per second square. So first of all we have to use the free body diagram over here. You can see it in the diagram over here. They have represented what are the different forces that are acting on the charge. First they have considered the charge in the left side. So they are repelling each other, so it should be the Fe value should be acting towards the left, right? Now in the its weight will be dragging it down, and that is what is acting as mg in the downward direction. The tension in the string is represented as T here, and you can see that T is making an angle of theta with the vertical side. Now we got to resolve T into two components as T cos theta and T sin theta. I have been seeing some children confuse this horizontal component with the vertical component all the time. So they have a confusion which has to be used as a cos component and which has to be used as a sin component. Please keep it in your mind. Whichever is, if you consider a vector, if it makes an angle with one side, that particular side will be adjacent normally, and automatically that will be the cos component, and the another perpendicular component should be sin component then. So here if you consider this to be theta, they make an alternative angle, so this also going to be theta, right? So automatically we can express the T is making an angle with this vertical side, so that should be taken as T cos theta, and the perpendicular, that is horizontal value, horizontal component, should be taken as T sin theta here. So now we have to consider the difference of these two because they are acting in the opposite direction, Fe and T sin theta. So we can express it as T sin theta I cap minus Fe I cap is equal to 0. Why we are taking it as minus Fe I cap? Because it is acting in the negative x direction. So T sin theta I cap minus Fe I cap is 0. Bring Fe I cap to the right side, becomes positive. I cap is getting cancelled, so T sin theta is Fe. In the same way, for the vertical components, we can write it as T cos theta j cap minus mg j cap. Why it is minus j cap? Yeah, good, because it is acting in the downward direction, that is along negative y axis. So it is equal to 0. So T cos theta j cap is equal to mg j cap. So T cos theta is equal to mg. So we are getting two equations now. Divide the first one with the second one. Sin theta by cos theta becomes tan theta. T and T getting cancelled. So Fe by mg in the right side. So tan theta is Fe by mg. Now what is the electrostatic force formula? Fe is K into Q square by R square. Remember it is Q1 Q2, but here both the charges are same, so we are taking it as Q, so it is Q square by R square, and we know the value of K, of course. Now what is this R? Distance between the two charges. Look at this diagram. R is equal to nothing but A plus A, that is 2A. So represent it, they have represented it with respect to L here. So it is taken as 2L sin theta, because sin theta is equal to A by L. Okay, so 2A is 2L sin theta. Now they are substituting the value of this over there in the tan theta. So first they are substituting the R value in Fe, and then they are substituting the Fe value in tan theta. So tan theta becomes K into Q square by mg 2L sin theta the whole square. So what is Q here? That is what we are going to find. So arrange it in terms of Q now. That will give you the equation as 2L sin theta root of mg tan theta by K. So you know that L is nothing but the length of the string. So you can substitute as 0.1, and theta is 7 degree. In the root, m is 10 power minus 3. That's a small correction over there, children. Actually they have given it as milligram, so they are converting it into kilogram. Should be getting it as 10 power minus 6, but here they have taken it as 10 power minus 3 anyway, and I think in the new book we may get some changes over there. Then g should be taken as 10, and then tan theta is 7 degree divided by K, 9 into 10 power 9. While substituting it, they are getting the Q value finally. Okay, so that's all about the second problem. So now let us enter into the last topic for today, superposition principle. See, so far we have discussed about Coulomb's law, which speaks about the force between the charges. Superposition principle also going to speak about the force between the charges, but there it was between two charges, but here it is for n number of charges. So a system will not have just two charges, it will have more than that. So Coulomb's law in a large scale is called superposition principle. That is the extended form of Coulomb's law. That is what is called superposition principle. So let us consider 5 charges here, which is represented in green color here, Q1, Q2, Q3, Q4 and Q5. So we are having 5 charges. All the 5 charges, we can see that they are represented in green color, right? So here we are going to find out what will be the total force experienced by this Q1 charge because of all the other charges. Okay, so in order to do that, we have to use the superposition principle. But first understand what is represented as the forces here. First of all, look into F12. So you can see that F12 is acting in the away from the Q1, that is away from the Q2 and Q1, because Q1 and Q2 are similar charges. So they are repelling each other. So it should act along the line joining them both, and that is why it is acting in the F12 away from the 2. So same thing is true in another force also. Can you tell me which is that force? Yeah, you are right, it is F14, and F14 also it is acting away from the Q1 and Q4, but line joining Q1 and Q4. But in the case of Q3 and Q5, we can see that it is acting along the line joining again, but they are acting in the opposite directions. Okay, so here F13 is acting towards the F13 because they are getting attracted towards each other, and F15 is acting towards the Q5 because in that case also they will be getting attracted towards each other. Okay, this is all about the forces now. So now what is superposition principle? How can we find the total force? We are going to see. So what is F12 now? K into Q1 Q2 by R21 square R21 cap. We are very familiar with that. F12 is nothing but force experienced by the first charge because of second charge. Now as I told you already, we are going to find out the total force. In order to do that, what we have to do is find out the individual forces and then add them all. Okay, so this is F12. What is F13 now? Very simple, replace 2 with the 3. So that will give you F13. So Q1 Q3 by R31 square R31 cap into K. Similarly, you can write it for F14, F15. So how will you find out the total force then? Just add them all. But you should not go for normal addition. You should go for vector sum, vector addition, because here we are dealing with the vector quantity, that is force. So we can extend the result to n number of charges. That is what is explained here. F1 total is equal to F12 plus F13 plus F14 up to F1 n. So we are writing, substituting the values of all those forces, and we are adding them all, and which will be a constant which is taken out. Obviously it is Coulomb's constant, that will give you the total force acting on it. So we can represent this or explain the superposition principle in this manner. So according to superposition principle, the total force acting on a given charge is equal to the vector sum of the forces exerted on it by all the other charges. Okay, ma? So this is all about superposition principle, which explains about force experienced by one charge because of all the other charges present in the system. So we are going to discuss a problem here that is going to be the last part of this session, and here Consider 4 charges Q1, Q2, Q3, Q4 that is equal to Q, that is equal to 1 microcoulomb, located at 4 different points on a circle of radius 1 meter as shown in the figure. So we are placing 4 charges on the 4 corners of the circle, and here we are going to see find out the total force acting on the charge Q1, which is placed in the right side. You can see that it is placed in the x-axis, positive x-axis in the right side. So due to all the other charges, what will be the force experienced? So we are going to make use of a superposition principle here. We got one similar problem in the exercise 2. So please listen carefully. You are going to do the exercise problem, and let me explain the example problem to you. So first of all, we have to find out the direction in which it acts, right? So find out the direction in which the forces act. F13 will be acting along the positive x direction because they are similar charges, so they will repel each other. So it should act towards the, that is away from the Q3 and Q1 and along positive x direction. Now look into F14 and F12. So they are also similarly, they are also similar charges, so they will repel each other. So it will be acting along F14 and F12. Now we have to resolve F14 into 2 components, as it is making an angle theta with the horizontal. So we can take it as F14 sin theta and F14 cos theta. Similarly, F12 also can be resolved as F12 sin theta and F12 cos theta. So here, before entering into the solution itself, we can easily see that F14 sin theta and F12 sin theta are equal in magnitude and opposite in direction. So if F14 and F12 are one and same, easily what you can do is you can simply cancel them both, right? So here obviously all the charges are similar, so automatically the force is going to be same and we can cancel each other. But in our book, for example problem, they have not done it like that, but while you are doing exercise you can do that. But one thing is, you have to start it in that way. F14 and F12 are one and same, and obviously the theta is same, so we can cancel them both as they are equal in magnitude and opposite in direction. So here what they have done is they have calculated the value of them individually, and then they have added up, and finally they have cancelled, right? So now what is F13? K q square by R31 square. So substitute the values 9 into 10 power 9, and q square is 10 power minus 12 because it is 1 microcoulomb. So 10 power minus 6 into 10 power minus 6 is 10 power minus 12. And in the denominator always you are going to have 4 because the radius is going to be 1 meter. So total distance is 2 meter. So 2 square is 4. So calculate F13, it is 2.25 into 10 power minus 3 Newton. Similarly find out F12, K into q square by R21 square. 9 into 10 power 9, 10 power minus 12 divided by 2 here, because R21 square, here we are speaking about the distance between them, right? So 2, so that will be giving you, the value will be 4.5 into 10 power minus 3 Newton. Now what is F12 here? See, we are resolving F12 into components. That is what is very important, and please remember we have to resolve it into components now. So before that, I think you may understand why it is R21 distance is given as 2 here. We have to apply the Pythagoras theorem over here, because this distance is, that is the radius is 1 and 1. So 1 square plus 1 square, that will give you, yes, root 2. So while you are squaring it becomes 2, and that is why 2 over here. So it is 4.5 into 10 power minus 3 Newton. Now resolve F12 into component, F12 cos theta I cap minus F12 sin theta j cap. So why it is I cap now and why it is minus j cap now? Come back to the diagram. So here you can see that F12 cos component is acting along the x-axis, positive x-axis, and F12 sin theta is acting along the negative j direction, and that is why it's negative y-axis, that is why it is minus j. So they are substituting F12 value, value over there, and then they are substituting the theta value too. Theta is 45 degree, okay, look at the diagram, theta is 45 degree. So what is cos 45 and sin 45? It is 1 by root 2. So substitute it and solve it, you are getting F13. Similarly, you can get the value of F14, and F14 is, here we can to add up the cos component and sin component. Both cos component and sin component are plus I and plus j, because both of them are acting along the positive x and y directions. So substitute it and you will find out the total force acting on the Q1 can be obtained as by adding all these components. So here we can see that they are rearranging it, and finally they are saying it as F12 is equal to F14, and we can cancel the jth component and hence getting the final expression. This is what I told you in the beginning itself, but there you have to start it with that line, and you have to make the cancellation there before proceeding in this manner if you want to proceed it in that way. And finally F1 is 8.61 into 10 power minus 3 Newton I cap on solving. So as it is I cap, it is acting along the positive x direction. Okay children, so that is all about the superposition principle and Coulomb's law. So we have discussed about Coulomb's law, aspects of Coulomb's law, and superposition principle. Okay, I have a question for you at this moment. We used to say always, because I wanted to find out the answer for this in the next session. Maybe I will start the next video with that particular the answer for that. See, we always say that A is proportional to B when then we will be removing the proportionality constant, and we used to introduce the proportionality symbol, and we used to introduce a constant called proportionality constant, right? If A is proportional to B, then we will be writing this A is equal to KB, and in all the cases it will have a special name, but general name will be proportionality constant. So why it is named so? Why it is called as proportionality constant? And what is the meaning of that constant actually? So get ready with your answers and check it out with me in the next video. Okay, so I want to conclude it with the quote now. Be like neutron. Neutron has neutral charge. Near it, it has both positive as well as negative charge, but it holds only positive charge. However, circus is done by the negative charge by moving around it, but the neutron never gets influenced. Neutron is a good particle. Be like neutron. I think you would have understood it better. Neutron, even though it is nearby, it has a positive charge and it is surrounded by an electrons too, that is negatively charged too, but always neutron is holding the positive charge all the time, right? So in the same way, we should stick to positive people, and we should have a positive vibes around us. We should have positivity all around us all the time. Okay children, thank you.